A car rolling off a production line every 4.5 seconds should be garbage, cheap, fragile, rushed, disposable. Tesla says it's their most reliable car ever. Only one of those statements can be true, because if a car built faster than your coffee finishes brewing can actually last longer than everything built before it, then the last 100 years of car manufacturing weren't careful, they were inefficient. And that's the part nobody in the auto industry wants to talk about. This video explains why Tesla's fastest-built car might also be its most durable, why legacy automakers are staying silent instead of fighting back, and why the Model 2 isn't just cheap transportation, it's an attack on how quality itself has been defined for a century. And once you understand what Tesla removed from manufacturing entirely, the 4.5-second number stops sounding reckless and starts sounding inevitable. Here's the mistake almost everyone makes. They think Tesla made factories faster. They didn't. Tesla deleted steps. For over 100 years, car makers followed the same unchallenged belief. More parts mean better engineering. More welds mean stronger frames. More inspections mean higher quality. That belief shaped everything. Factory layouts, labor models, even how consumers learned to trust cars. Tesla rejected it completely. Not improved it, not optimized it, deleted it. And that single decision is why a Model 2 can exist every 4.5 seconds, while legacy factories still need close to a minute just to finish one car. This is why competitors aren't responding publicly. Not because they don't understand what Tesla's doing, but because their factories physically cannot copy it without admitting their entire manufacturing philosophy is obsolete. And that raises a much bigger question than speed. If a car built this fast can still meet or exceed reliability standards, then what does that say about the way cars have been built for the last 100 years? Before we go any further, you need to see the rule Tesla broke, because everything else in this story flows from that moment. For decades, every factory manager was taught the same thing on day one. If something goes wrong, slow the line down. Speed and quality were treated like opposite ends of a lever. Push one up, the other comes down. Tesla decided that logic was backwards. The Model 2 doesn't move this fast because Tesla ignored quality. It moves this fast because Tesla removed the things that create quality problems in the first place. Here's the rule Tesla follows, and almost no one else does. The best part is no part. The best process is no process. That sounds philosophical. In manufacturing, it's brutal. Every bolt is a potential misalignment. Every weld is a future crack. Every handoff between machines is another chance for error. Legacy factories manage this risk by inspecting constantly, reworking mistakes, and slowing production when defects appear. Tesla chose the opposite approach. Instead of catching defects later, they redesigned the car so defects are harder to create at all. That one decision rewires the entire factory. Take a traditional compact car. The rear structure alone is built from dozens of stamped panels, hundreds of welds, and multiple robotic stations that must stay perfectly synchronized. If one weld drifts slightly out of tolerance, the car keeps moving. The defect hides. It shows up months later as a rattle, years later as frame fatigue. Tesla looked at that system and removed it entirely. The Model 2 uses massive single-piece castings that replace large sections of the vehicle with one solid structure, formed in seconds, with no welds to inspect and no alignment to correct later. That's why the line can move at a speed that sounds impossible. Less to assemble, less to inspect, less to fix. But here's where this stops being comfortable. When you build this way, you don't get second chances. A traditional line can stop, rework, and recover. A hyper-fast line cannot. Tesla is making a dangerous bet. They're betting their manufacturing precision is good enough that slowing down would actually make things worse, not better. That's the part competitors don't want to admit. Because copying this doesn't mean upgrading equipment. It means admitting their factories were designed around human correction, not precision. And that's where speed stops being the enemy of quality. Judgment is. Once you remove judgment from the process, speed stops creating errors. It exposes them.
And that brings us to the machines Tesla is staking everything on. Because this system only works if those machines never lie. Everything about the Model 2 production line depends on a small number of machines operating perfectly all the time. There is no buffer. There is no manual backup. There is no close enough. At the center of this system are next-generation giga-presses, machines so large they replace what used to be entire factory buildings. Traditional compact cars require dozens of stamped parts just to form the rear and front structures. Tesla pours molten aluminum into a single mold and creates an entire structural section in one shot. Seconds instead of minutes. That's why the line moves the way it does. But it's also why the line is unforgiving. If a welding robot fails on a traditional line, production slows and humans step in. If a gigapress fails, everything stops. No partial output, no workaround, no improvisation. That's the risk Tesla accepted. And they didn't accept it blindly. The Model 2 factory is designed as a closed-loop system where machines verify each other in real time. If a casting cools outside expected parameters, it's rejected instantly. If alignment data shifts, the next station refuses the part. If vibration or torque trends drift, the system pauses before defects propagate. This is how Tesla replaces human judgment with machine certainty.
And it's why critics are nervous. Because a system this automated doesn't degrade gracefully. It either works or it doesn't. There is no mostly fine. And that raises the uncomfortable question Tesla doesn't answer directly. What happens in edge cases? Power fluctuations, material inconsistencies, thermal stress during peak cycles, unexpected wear at unprecedented production speeds. Legacy factories survive these because they're slow and forgiving. Tesla's system is fast and unforgiving. If Tesla is wrong, the failure won't be subtle, it will be public. A single recurring defect would ripple through tens of thousands of cars before anyone outside the factory sees it. That's why competitors aren't laughing, they're watching. Because if Tesla proves this works at scale, it invalidates decades of manufacturing logic overnight. But here's the part most people miss. Machines were never the real bottleneck. Coordination was. You can cast aluminum in seconds, but a car isn't aluminum. It's batteries, electronics, software, calibration. Missynchronization by even a moment and the whole line slows. That's why legacy automakers don't even try to move this fast. Tesla attacked that problem by redesigning the car itself. The wiring architecture is simplified. The number of control units is reduced. Modules arrive pre-validated instead of tuned on the line. Tesla didn't just remove parts, they removed decisions. And decision-making is slow, even for robots. At 4.5 seconds per car, seconds are catastrophic. So Tesla made a ruthless rule. If a module can't be installed in one motion, it doesn't belong in the car. If software needs calibration after assembly, it gets rewritten. If a supplier can't deliver near zero variance, they're replaced. That's why this speed isn't really about robotics, it's about predictability. But predictability breaks down in one place: batteries. Cells vary, chemistry varies, thermal behavior varies. Battery inconsistency kills speed. That's why most automakers slow the line at pack installation. Tesla couldn't afford that, so they standardized the Model 2 battery not for maximum range, but for manufacturing tolerances. Fewer variants, narrower operating windows, less post-assembly testing. That trade-off is the most fragile point in the entire system. If consistency holds, the line flows uninterrupted. If it doesn't, the 4.5-second promise collapses. And that leads to a realization most buyers won't like. Tesla didn't design the Model 2 primarily for consumers. They designed it for fleet-level predictability. A car that behaves the same every time, charges the same way every time, consumes energy the same way every time. That's perfect for automation. It's risky for resale psychology. And this is where the story flips from engineering to consequences. Because once a system is this optimized,
Failures don't show up slowly. They show up later at scale. Traditional factories rely on human senses. Someone hears a rattle. Someone notices a misalignment. Tesla removed most of that, not out of arrogance, out of necessity. Humans can't operate at this speed, so Tesla moved quality control upstream into software, sensors, and data models. That's powerful and unforgiving. If a tolerance threshold is wrong, every car inherits the mistake. And when production runs in the millions, mistakes multiply fast. This is why Tesla doesn't fear recalls the way other automakers do.
They fear interruption. Stopping this line doesn't just cost money, it breaks the economic logic of the Model 2. The cost advantage only exists at extreme scale. Slow the line and the numbers stop working. That pressure changes decisions. It means data replaces instinct. Software flags replace human judgment. Early warning signals become everything. And it turns buyers into something else entirely, not just owners, data nodes. Every vibration, every charge cycle, every temperature swing. The car reports back continuously. Problems must be detected and corrected faster than the factory outruns them. This isn't just a car, it's a stress test of Tesla's entire operating philosophy. Not whether they can build fast, but whether they can learn faster than they build. And if they can, the auto industry loses its last defense. Because if speed, cost, and quality coexist at this scale, legacy platforms become obsolete overnight. Factories designed for 60-second cycles can't adapt without destroying capital. That's why competitors aren't talking.
They're not afraid. They're waiting. Because the verdict doesn't come from analysts. It comes from driveways. And that brings us to the final truth. A car built in 4.5 seconds forces buyers to confront something uncomfortable. Speed feels cheap even when it isn't. For a century, people equated quality with time. Slow meant careful, fast meant careless. Tesla is asking buyers to unlearn that instinct. Some never will. They'll hear 4.5 seconds and think corners were cut, even if the data says otherwise. Others will see a system so precise it doesn't need time. If early owners report quiet cabins, consistent fit, and stable performance, the narrative flips. Speed stops being the risk. Slowness becomes the liability. Used markets feel it first. Insurance models follow suit. Fleet buyers move last, and they don't care about feelings. They care about cost per mile. And if the Model 2 survives that scrutiny, Tesla's advantage compounds. So here's the real question. Not whether you'd buy a Model 2, but whether you'd trust a car built faster than your coffee if it proves it lasts longer than anything built before it. Because there is no middle ground. Either this is the future of quality, or it's the most expensive manufacturing mistake in automotive history. And by the time the industry agrees which one it is, the shift will already be over. If you want to stay ahead of what Tesla is actually building, not the headlines, not the hype, subscribe. Because after 2026, this won't be about cars anymore. It'll be about who still exists.